Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. As we all know that today is Republic Day, we as Indians are celebrating 77th Republic Day today, and I wish you all a very happy Republic Day. And let us join our hands to commemorate into one goal, which is to improve India. And while studying, also we are doing that. So as and when you study, just stay focused so as to you can add on to the developing India. And let us begin today's lecture with a new topic, a new method, which is known as Euler's method. In the previous lecture, we did Picard's method. Euler's method is also for differential, is also for solving differential equation. But Picard's method was for solving differential equation where x independent variable were the powers of dependent variable, but here the x values and the y values are when given differently, then we use our Euler's method. And Picard's method was an iterative method, but Euler's method is a step-by-step method. Let me tell you what is Euler's method, and we'll solve some PYQs based on Euler's method so that you can understand the concept better. And it is one of the most important topics from an exam point of view. Every year, questions have been asked from Euler's method in 2025 also. Two questions, two or three questions were asked from Euler's method only. So let us begin. Euler's method. What is, if I tell you the formula directly, if I have to calculate y n plus 1, then the Euler's method formula is yn plus h into f xn yn, where yn plus 1 is the value of the dependent variable at n plus 1th. Yn is the value of dependent variable at nth term. H is the width or the difference between the values of x's, as we notice while going forward. And fxn yn is the function which includes both xn and yn. And fxn may be written in question like this also. So that is how you can derive this, or y dash or something like this. That is how you can see. So this is the formula for our Euler's method, and it is a short formula, but it is very important. Suppose if we have to find Euler's method for first term, then it is y naught plus h into f of x naught and y naught. In Picard's method, we used to keep this y naught common in all the terms, but here if we have to calculate y2, then it will be equal to y1 plus h of f x1 y1. As you can see here, we have taken y1 instead of y0. So it is a step-by-step method. As we move on, we'll find that we are moving with steps. Now let us do some questions. All of the questions are from PYQs, and nothing has been taken away from that, so that you understand how the questions, the how you understand how the concepts of how question arises in the examination. Let us see our first question. In this question, they have just asked you the iterative formula for the solution of differential equation. This they have given us this differential equation, and we have to see what is the iterative formula. Iterative formula, it can also be considered iterative formula because we are moving step by step here. So here you can see that h is there. So this is not Picard's method, this is Euler's method. I have told you how the formula n plus 1 n. There is no n, so this option gets cancelled. N plus 1 n n n. Here it is no n, it is 0, then this option also gets cancelled. N plus 1, here it is 0, this option also gets cancelled. N plus 1 n n n. All of them are there, and now we see the formula yn plus 1 is equals to yn plus h into fxn yn. So D option is your correct answer of Euler's formula. They might ask you these this kind of simple questions in the examination also, and they might ask you to the calculation ones. Let us move forward to calculative ones. So this is our next question, which is Euler's method is applied, and we have to state things. I hope that you all have seen the question. Let us move aside this. Let us move this aside. So here, Euler's method is applied for initial value. We have been given f x y equal to lambda y naught is the value given is 1, and x naught's value is 0, and lambda is less than 0. Then the method is stable absolutely for step size h that satisfies. Now we have to see, we all know that there is one more concept in this questions. Then when the method is absolutely stable, then the h varies between h is less than modulus of h is less than equal to 1. So let me tell you how do we calculate that. Suppose we have to find y1, yn plus 1. Let me write the formula, which is equals to yn plus h into f xn yn, right? Now if we place here y n plus 1 equals to yn is nothing but 1. Suppose we are taking the value of y1. y1 is equals to y naught. Y naught is nothing but equals to 1 plus h into f x and yn. Here yn, in place of yn we'll put y naught, and this will be equal to 1 plus h lambda. Now this y1, modulus of this y1 should always be less than equal to 1, so that the method is stable, absolutely stable. Now putting the values here, 1 plus h lambda in modulus is less than equal to 1. Then we can say that minus 1 is not less than equal to, it is only less, not equal to sign, is less than 1. Minus 1, 1 plus h lambda less than 1. If we substitute it, it will be h lambda less than minus 2, 0. This is our range of h that is coming here, and when we compare it here, then D option is correct. Minus lambda h lies between 0 and minus 2. Okay, I hope you understood the concept, the absolute stable, how to calculate absolute stability. Now moving forward to a similar kind of question. In here they have asked us the step size h, the interval of step size h. Again we have to do the similar things. We know that here f x y has been given to us as minus 8y, y naught is equals to 1, and x naught is equals to 0. Same things again, we have to calculate the interval for h. Now we know that if we calculate for y1, y1 is equals to y naught plus h into fx1 y1, fx naught y naught. If we put here the values of y naught, because x is not present, then we'll get it as minus 8 into y1, y naught, which is 1 only, so directly I'm putting that, which is equals to 1 minus 8h. This is our y1. Now for it to be absolutely stable, we have to put it in the modulus sign and should put it less than 1. Then only it will be absolutely stable. Now removing the modulus sign, we'll be left with minus 1, 1 minus 8h minus is less than 1. If I subtract 1, it will be minus 2 less than minus 8h less than 0. And if we multiply all of the terms by minus, then the sign changes. It will be 2, 8h, 0. And now we have to divide with 8 also, because we need to find the interval for h. So 2 upon 8 greater than h greater than 0 upon 8 is 0 only. So it will be h will lie between 0 and 1 upon 4, which is our option number B. The limits are 0 and 1 upon 4 to be stable for H. I hope that this concept is clear with all of you. Moving forward to another kind of questions that the examiner asks us. This kind of question, I hope that you've noted it down. Let us solve this. So we have been provided with yx and Euler's method, and we have to calculate y 0.3 and step size is h. Now f xy has been given to us as 1 plus x plus y naught is equals to 1 and x naught is equals to 0, and step size also is equals to 0.1. We have to calculate for y 0.3, means we have to move forward with step size 0.1. We have to take 3 steps: 0.1, 0.2 and 0.3. So first of all, let us consider at x equals to 0.1. Let us consider this. So y1 should be y 0.1 should be equal to y naught, which is 1, plus fx plus h. H is nothing but 0.1 into 1 plus x plus y. X naught is 0, y naught is 1, so it will be 2, which is equals to 1.2. This is our y naught. Now this value is for y1 and this value is for x1. Now next step we have to find at x2 equals to 0.2, because we are moving with the with 0.1. So with width 0.1. So y2 of 0.2 should be equal to, now here it will be y1. So y1 has we have calculated y1 here as 1.2. Then h is nothing but 0.1, and then here we have to calculate, put x1 and y1. 1 plus x1 is 0.1. 1 plus 0.1 and y1 we have calculated is 1.2. So here we will be getting it as 1.2 plus 2.3.23, which will be equal to 1.43. This is y2. Now the third iteration at x3 equals to 0.3 is nothing but y3 at 0.3, which is equals to, now we will take y2 here. Y2 is 1.43 plus here we'll calculate for uh, h 0.1, then 1 plus x2, which is 0.2, plus y2, which is 1.43. So it will be nothing but 1.43 plus 0.1 into 2.63. 2.63 will be 1.43 plus 0.263, which is nothing but equal to 1.693. y3 is nothing but equal to 1.693, as we have calculated here, which is our option number C, as you can see on the board. This is how we calculate the actual calculation in the examination, and I have calculated on a slower pace so that you can understand the concept, and as and when you practice more and more of questions of these kinds, you will be thorough with the concept and you will be able to solve it within a limited amount of time in your examination. Now moving forward to another this kind of question only. First of all, let us solve this kind of question exactly. So it has been given to us, the question is like this, which has been given to us here. In every question you'll notice that they have given us Euler's method, and which plays a very important part. uh, if they want us to solve it with Picard's method, they'll mention that, and if they want us to solve it with Euler's method, they'll mention that as well. So no need to worry about when to appear and when not to appear, or what kind of question. Here y dash has been given, which is nothing but I have told you in the early time that it is nothing but fxy, y plus 2x minus 1, and the value of the solution y zero point 0.2 has to be calculated. Means with h we'll move at, here one thing is missing, which is y naught is equals to 1 has been given in the question also. There must be printing mistake in here. So we have been provided with the values of y naught and y1. Y naught is equals to 1 and x naught is equals to 0. Sorry, y naught and x naught. This has been provided to us, and we have to find y 0 0.2. So first of all at x 0.1, then x to 0.2. At x equals to 0.1, which is x1. If we have to calculate for y1, which is y naught plus h has also been provided to us as 0 0.1. 0 0.1 into y naught, we have to replace it with y naught and x naught. Y naught is 1 plus 2x naught, which is 0, minus 1. This whole term becomes 0 and our y1 is coming out to be 1. So we have calculated this. Now at the second point, we will calculate x2 at 0.2. Then y2 will be y1, which is 1, plus h, which is 0.1, plus y1. Here we have to replace it with y1 and x1. y1 is 1, plus 2 into x1 is 0.2, plus minus 1. This plus and minus 1 will get cancelled, and this will be 1 plus 0.02, which is 1.02. And our answer in the question, they have just given us one extra 0, and this C option is our correct option in the examination. So these kind of easier questions also has been asked. The previous one which we did has also has been asked, which requires more of calculations, and direct formulas are also asked in the questions. Now let us move to this last question. I hope that you've noted it down. So here they have asked us two things. First of all, they have asked us the value of y1 for this solution, and second, the direct formula, if we apply direct formula for y point 2. So first of all, let us apply Euler's method. If we apply Euler's method, then fxy has been given to us as minus 2xy square. X naught is given to us as 1, 0, and y naught is given to us as 1. These are provided to us. Now if we calculate this at h also has been provided to us as 0 0.2. If we calculate this at x1 equals to 0.2. Now here, as you notice that x is also 0.2 and h is also 0.2. So we have to just attempt it in one step only. The first step will only give us the answer. We don't have to go to we don't have to go to further. If x would have been 0.4, then we would have been taken zero point 0.2 as first step, then 0.2 plus 0.2 will be 0.4. So it would have finished in two steps. That we don't have to do here. It will be finished in one only. So y1 should be equal to y naught, which is 1, plus h, which is 0.2, plus minus 2xy square. Here x naught and y naught square, but x naught is 0, so all are in multiplication, so it will be 0 only, and our y1 is nothing but 1. So we have calculated y1 is equals to 1 by Euler's method. In the second step, they have asked you to find this y.2 by numerical solution. And if we apply numerical solution, see, Here we have been given dy by dx should be equal to minus 2x y square. If we place y is on one side and x on other side, this will give us 1 upon y square dy should be equal to minus 2x dx. And if we take integration on both sides, then we'll be getting as minus y raised to the power minus 1, I am directly writing it, minus 1 upon y equals to minus x plus c, minus x square plus c. Now if we put the values of x and y in here, we'll get the value of c as equals to minus 1. Putting the value, we get the value of the constant. Now if we put the constant here, it will be minus 1 upon y equals to minus x square minus 1. Taking minus common on both sides, we'll be left with 1 upon y equals to x square plus 1. And therefore, y will be equal to 1 upon 1 plus x square. Now they have asked us to calculate y at 0.2 when x is at 0.2. If x is at 0.2, we'll be doing it 1 plus 0.2 whole square, which is 0.04, which is 1 upon 1.04. And if we solve this, which is 0.9615. This is our value for y.2. These two values we have calculated, y.2 and y1. And in the question, they have asked us to calculate this y.2 minus y1 modulus. y.2 is nothing but 0.9615 and y1 is nothing but minus 1. If we solve it in modulus, it will come out to be minus 0.30, 0. In modulus, it will be minus 0.0385. And outside the modulus, minus will get cancelled and we are left with 0.0385. This is our final answer, which is our option number B. This is how you calculate 4 numerical methods in integration. This formula is the one I am highlighting with pink is for integration, and this little formula was for Euler's method. All of this you must be knowing, and all the integration formulas you must be knowing to solve these kind of questions in your examination. I hope that all of the questions were beneficial for you, and these kind of questions has been asked. Now you know what kind of questions are being asked in the examinations, and you can solve like them in your practice sessions, and then you can then you will be having some confidence in attempting them in examination point of view with a limited amount of time, saving times for the ones that really require times in the examination. So that's it for today's class. I hope that I was able to make you understand these concepts, and if you face any doubt in any of the questions or any of the topic, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best and thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.